Hey there. Alright, so in this video we're going to be walking through how to conduct a confirmatory factor analysis. Um, but before we get into that, let's talk a little bit about our data and why we would actually want to even run a confirmatory factor analysis. Alright, so first things first, to get the data set, I went to Import Dataset and I clicked from Excel, and then I browse from my data set, which is saved to my desktop, I believe. Here we go. Oh no, I remember now. I saved it to my Dropbox. Anyway, so I loaded that data set and clicked OK once I found that, and then it came up here, and then I loaded that file into this bit of code here, our read Excel command. So essentially, I'm just loading the data here in these lines of code that we're going to be using to run our CFA. And this data set is essentially a motivational state data set using the reversal theory framework. So we're looking at differences in people's motivational states over time, through different experiences, different situations, etc. And we have two administrations, or 2 time points that we actually administered the questionnaire, and that was time 1 was in 2005, and time 2 was in 2006. So here we see we have all these different variables here. I think about 40 items, I believe. Yeah. All right. So the purpose of a confirmatory factor analysis is that we want to get an understanding of the underlying factor structure. So we might have run a exploratory factor analysis where we're trying to understand the underlying factor structure of a questionnaire, because we want to know how the variables how the items load on the constructs that we're trying to measure, right? So typically, when we have a questionnaire, we're trying to assess a latent construct. And a latent construct is a construct that's abstract. We can't really see it, we can't interact with it, but we believe that it exists because we can see maybe behaviors of that construct, for example. So it's like satisfaction. We can't see the variable, the latent variable satisfaction, but we can see behaviors or characteristics of satisfaction where people are happy rather than sad and things like that. We can see those behaviors, and we can measure associated behaviors that we believe to comprise the latent variable satisfaction. So what we're trying to do is say, okay, we have these items that we think are assessing these latent variables that we have of interest. So in this case, we're looking at motivational states. The question is, okay, how well do we think these factors load onto these latent constructs? And typically you would run an exploratory factor analysis when you're not sure of how many constructs you actually have in a data set. For confirmatory factor analysis, we already have an idea of which constructs we have in our data set, and we already have some idea of how the factor loadings will kind of play out with respect to each of these constructs. So confirmatory is essentially to confirm that we have the number of, the number of constructs that we think that we have, and to see how well they're represented by each item, as with respect to each factor loading for a particular item, and how it, in terms of wording and verbiage used in the item, adequately reflects our latent construct. All right, so we loaded our data set, and then we're going to load the lavaan package, which is essentially the package in R that lets you run things like confirmatory factor analysis, exploratory factor analysis, latent growth curve modeling, structural equation modeling, things like that. So we're going to load that, and once we load that, we have to then specify the indicators for our model, our CFA model. So in this case, I had already run an exploratory factor analysis on the data set that I'm using here. So I already knew that there was such a thing as a self factor, so like self-mastery, self-other, things like that. And I already knew that there are, self-mastery, self-sympathy, and other mastery, other sympathy, as well as a rebellious motivational state. And so I set about to see which of these indicators I had, these here. So this would be my three constructs. So, and this would read as, so I'm pushing all of this information into my CFA Model 1. What this information is basically saying is, okay, I have this self construct, and as defined by each of these indicators, and I've listed out my indicators here based on my scale that I have. And again, those three constructs are self, other, and rebellious, and they're defined as such. And this is how you would define it in the context of our Lavaan package. All right, so once we defined our model, we then want to run our fit indices to see how well these indicators fit with respect to the measurement of our latent variable. Because some items load more strongly than others, right? So we want to see how well our model fits. Right, so and to do that, we're defining what kind of model we're actually running. In this case, we're running a CFA, and then we're specifying the model summary that we want to display not just a summary of the model, but also, or with particular emphasis on our fit indices. All right. So I'll tell you what, I'm going to go ahead and run this, and as I talk through it. There we go. Let that run. All right. So now we've run our first model. This bit of code here is breaking out our grouping variable. So basically, we're creating an individual CFA for group 1 and a CFA for group 2, or so a subset, essentially. And in my case, rather than using a grouping variable like gender, my data set, my questionnaire, was actually administered at 2 different time points, right? So I want to see, are there differences in the factor structure, the underlying factor structure within my data set at different time points. So is the factor structure different across time? So I have time 1 is 2005, time 2 is 2006, and we've indicated that there. All right, so now I want to run this. Like I said, this runs our overall model. This runs the fit indices of our overall model, and this separates our observations in our data set by our grouping variable, this bit of code here. And then now I want R to give me the fit indices, the fit measures for each sub data set, if you will. So for year 1, I have a set of fit indices. For year 2, I have a set of fit indices, and I want to run that, right? And so that is essentially our set of CFAs that we're going to be running. And then line 33 here, 33, 34, we're now looking at our measurement invariance indices, right? So we want to know information like, do the factor loadings vary across time, and or are the items that are measured in the questionnaire, are they being measured the same across time? So we're going to take a look at each piece of that information as we walk through the rest of this data set here, or the output rather. All right, so that is how we would run each piece of that information. Now let's go and see what our output gives us. All right, so this is our first model. This is our free model. We haven't constrained anything. We haven't. All we did was tell R to run the model in its entirety and spit out some fit indices. So here we see. Ideally, what we're looking at in terms of model fit, we want to take a look at our chi-squared indices, our degrees of freedom, and of course our significance value. But we also want to take a look at our comparative fit index. These are different indices for fit again. So that is our comparative fit index, our RMSA, and our SURMR. All right, and interpreting each one of these. So, for example, we have our CFI, which is typically a CFI is thought to be acceptable at greater than 0.90, but good fit for CFI is considered to be greater than 0.95. That is the general cutoff, but there's no really hard and fast deadlines for a lot of these cutoffs for these fit indices. But it's more like guidelines for each one of these. For our RMSA, unacceptable is considered greater than 0.10. Good fit is considered less than 0.06, and acceptable is roughly 0.8. So ideally, we're shooting for 0.06, less than 0.06 for our RMSA, and then for our SURMR, good fit is considered to be less than 0.05. And I'm pulling some of these guidelines for these cutoffs from Hare, Black, and Babin chapter, as well as Heumann-Bentler, right? So there's different conceptualizations of what is appropriate, what is, I guess, what is more restrictive, what is more concise with respect to some of these indices. But again, there's really no hard or fast deadline or hard or fast cutoff there. All right, so we're going to take each one of these in turn and see if our model is in fact significant. So we have our chi-squared, which is 547.7, and it is significant with a degrees of freedom of 51. Okay, good. All right. And again, CFI, we want to be greater than 0.95. That's pretty close, so pretty good so far in terms of fit. And then we have a RMSA of 0.07. That is, it's not great fit, but it's not too terribly bad either. And we have, for our SURMR indices, index, we have a value that is less than 0.05. So overall, given our indices, I would argue that the first model has good model fit. And let's take a look at our latent variables and see that, okay, yep, looks like all our variables pretty much loaded as we expected. And we have our self construct, our self latent variable, our otherness latent variable, and our rebelliousness latent variable. All right, so this is our second model, or excuse me, the model broken down by year. So this is our for 2005, year one. Again, our chi-squared is significant. Our comparative fit index is okay. I suppose it's ideally we'd like it to be about 0.95. Then our RMSA, which is 0.075, getting a little high. It's going in the wrong direction. as you can see. And then for Surmer, we still have a value of 0.049, which is still less than 0.05. So arguably, I would say that this model still has good fit. So the model broken down by year 1, 2005, has good fit. Same information there. All right, and then our CFI for the second year seems to be roughly okay for CFI. The RIMSA is 0.76, getting a little higher. Then we see that SMR, or Surmer variable, or indices rather, index, is above 0.05. So I think in this case, I would say that this model isn't fitting as well as the first one. So there's a difference between 2005 and 2006 in terms of model fit. All right, so we got that. And now we're ready to walk through our invariance analyses. So we're looking at metric invariance, scalar invariance, and mean factor differences for each one of these. All right, so here you'll see we have configural, loadings, intercepts, and means. But what is that really telling us, right? Oh, I forgot to point important part. I guess I can show you with this. These estimates here, these estimates, well, I'm not going to highlight the whole thing, but these estimates here, and here, you get the point. These are basically our factor loadings that are telling us how each of these items is loading onto this factor, how strongly that is being loaded onto this factor. And typically, this is really high. We wouldn't expect factor loading greater than 1, but I believe from my understanding of the Lavon package, one of the things it does is restrict variance to 1, and so we're seeing that that'd be the reason for these high factor loadings that we're seeing. Typically, you'd get something more like 0.78, that kind of thing, versus 1.127. That's pretty high. But given that we're running a confirmatory factor analysis, we would expect that some of these loadings would be higher because we already have some idea of how they're going to load in the first place. Right, so back to our invariance measures. Our configural measure is essentially the baseline. We're testing to see whether or not the items in our scale are being measured the same across administration. So from year 2005 to year 2006, time 1 to time 2, is our questionnaire assessing the same items. Ideally, we would hope that doesn't change. And then for metric invariance, now we're, in addition to making sure that the items are measuring the same across administrations, now we're looking at factor loadings to make sure that the factor loadings are roughly equivalent across administrations. And then with scalar, we're looking, this would be scalar here, we're looking at the intercepts. So are the intercepts equivalent across administrations? Basically what we're doing is increasing in terms of restriction. We're restricting our factor loadings, restricting the variance of the intercepts, and the means, I believe, and seeing, okay, how does our model function with respect to each of these constraints. And our factor differences there, our mean differences, is testing to see whether whether residual error is relatively equivalent across administrations. All right. Now, what are these invariance measures good for? In the context of a CFA, one of the things that allows us to do is determine different types of change. All right. So, for example, we want to know we administer a questionnaire at time 1, and then we administer a questionnaire at time 2, do we expect that when we see a change in those responses, we want to know, we want at least think we know or have some sense that that change is due to the in particular intervention that we administered, or whatever environment or situation that we had participants participate in. We want to know that what the researcher did contributed to the change, rather than having change due to measurement bias, rather than having change due to different understandings of the construct, changes in the criterion, etc. And that's what some of these, or that's what these invariance measures or indices tell us, right? But I'll talk more about that in the discussion for the results write-up for this assignment. But yeah, so that would be how we conduct a factor analysis in R. Cheers.